Okay, today we're going to look at section 6.3 and the essential question is what operations can be performed on a pair of functions to obtain a third function. Okay, so we can add, subtract, multiply, or divide combinations of functions to create new functions. A couple little definitions here. Domain, okay, we talked about that earlier in the year. Domain is the set of all possible inputs of a function. Okay, function notation looks like this. We would read this as f of x. Okay, it could be g of x, it could be any letter, but it's basically like y equals. Okay, but it's function notation. Okay, operations on functions. If f of x and g of x are functions, a new function can be found by applying the basic for operations. So for example, a new function called h of x could be equal to f of x plus g of x. Okay, in that case, or in any of these cases, the domain of h of x would consist of the x values that are in the domains of f of x and g of x. All this is on page 428 in your textbook as well. Okay, so we're going to go through a couple quick PowerPoints here. Okay, here's the first one. Adding and subtracting functions. So here's f of x, here's g of x. We got 4x to the 1/2 power, and g of x is negative 9x to the 1/2 power. If I want to add those, I simply add the functions similar to like we were doing in the last section. And we're going to add the 4 and the negative 9, get negative 5x to the 1/2 power. Okay, if I wanted to subtract those functions, same thing. Well, I'm subtracting. So you got 4x to the 1/2 minus negative 9x to the 1/2. We're going to get positive 13x to the 1/2 because that's going to become a plus there. Okay, the domains of f plus g and f minus g are the domains of the individual functions themselves. They're saying the domains are all non-negative real numbers. So why would that be? Because our initial function x to the 1/2 power is the same as the square root of x. So we cannot square root negative numbers. So that's why the domain is all non-negative real numbers, all positive numbers. Okay, here's another example. Now we want to multiply these two functions to get a new function. So when I multiply these functions together, I need to add the exponents. This is x to the 1, this is x to the 3/4. We just add those together. This would be 4/4 plus 3/4 is 7/4. Okay, division. So I got 6x over x to the 3/4. So now I'm going to subtract those exponents. 1 minus 3/4 is 1/4. 6x to the 1/4. The domains, all real numbers again because our exponent, well, let's see. The domain consists of all real numbers, and the domain of g consists of all non-negative real numbers. So the domain of the product of the two are all non-negative real numbers. So it's all values that work in both functions. Now, why are we not including negative numbers? Because technically we're taking an even root in the g function. So the g function has a domain of all non-negative real numbers. Now the domain of this function cannot include 0 though, because we're dividing by 0 there. Let's see if they mention that. Because g of 0 equals 0, the domain is restricted to all positive real numbers, not including 0. Okay. Here's a quick example. So for a white rhino, heart rate R and lifespan S are related to body mass. Okay, so here's our heart rate equation and our lifespan equation. So find the product of heart rate times lifespan. Explain what the product represents. So We just need to multiply those two functions together. In this case, we're going to multiply the number times this power here. And then when I multiply the exponents, I'm going to add the powers there. See what we get. Okay, so when I multiply those, I get this value, and I add those exponents, I get negative 0.05. Okay, and then they move the decimal 3 spots over, added 3 to the power like we did before when we talked about scientific notation. Okay, now what does R of M times S of M represent? The heart rate times the lifespan would equal the number of heartbeats in a lifespan. Okay, so give that problem a try, or wait. F of x plus g of x. If I add those together, try to write that down, what would you get? Okay, here's our solution. 5x to the 2/3. So we're just adding those together. Give this one a try. See what you get. Negative 9x to the 2/3. So we're subtracting this minus this. Okay, the domains, now we have notice we have an odd root. So we can take the odd root of any number. So the domains in this case are all real numbers for both of them. Okay. How about the product of the two? F of x times g of x. We get 3x to the 6/5 because this is x to the 1 times x to the 1/5. I'm adding the powers. 5/5 plus 1/5 is 6/5. Okay, division, you would subtract the power. So you got 3x over x to the 1/5. So 1 minus 1/5 is 4/5. Okay, so let me escape on that one. I think we're good for that PowerPoint. So I'm going to move on to the next PowerPoint here. There's 2 PowerPoints. Here we go. So I can minimize that. Okay, now we'll talk about the composition of a function. So let's say I have 2 functions, f of x and g of x. Find the value of g of f of 3. So the way you do this is you plug 3 into the f equation, get an answer, and then plug that answer into the g equation. Okay, so when I plug 3 into the f equation, 2 times 3 is 6, minus 7 is negative 1. Then I plug that into the outer equation, the g equation. Negative 1 squared plus 4 is 1 plus 4 is 5. So that would be my result on that one. Okay. Now, how about the composition of functions in general? Okay, f of g of x. So now we're coming up with a new function by plugging one function into another function. Okay, so I'm taking 5x minus 2, which is g of x, and substituting it in for the x in the f equation. So where the x was, now I have 5x minus 2. And now I can simplify that down. Negative exponent, so I put it on the bottom, make it positive. The 4 stays on top. Okay, so when I find the composition of functions in general, I substitute the initial function in. How about the other way, g of f of x? So now I'm plugging the f of x equation into the g equation. Okay, so where the x is here, I'm substituting this in, and that's what I get there. 4x, this should be a power of negative 1. So then you can multiply 5 times 4 and get negative 20x to the negative 1. And then you could put the x on the bottom, make it positive. X to the positive 1. Okay. And then, so f of x would mean you take your f of x function and plug it back into itself. So it would look like that. So I'm plugging the 4x to the minus 1 into the 4x to the minus 1, and then substituting that down. Okay, so they distribute the negative 1 in there. So 4 to the negative 1, x to the positive 1, because the product is 1. So then you get 4 to the 0. 4 to the 1 and negative 1 is 0, so you could just get x. Okay, so that's that one. I'm going to skip over this to save some time here. And move on to this. Okay, so let f of x and g of x be this. What would g of f of 5 be? So now I'm plugging 5 into the f equation. 3 times 5 is 15, minus 8 is 5. Then I plug that result into the new equation. So then 5 squared is 25. Oh, wait. Yeah, so I plug that in there, and I get 15 minus 8 is 7. And then I substitute the 7 in here. 7 squared is 49 times 2 is 98. Okay, do it the other way. Plug the 5 in here. What would I get there? 5 squared is 25 times 2 is 50. Plug 50 in here. 150 minus 8 is 142. So that's how we would do those. Let's see, I'm going to skip by these ones. You could try those on your own. One last part here. So I have two functions. Find f of g of x. So if I find this one, I'm plugging the g of x equation into the f of x equation. So it would be this one right here. Because the 2x minus 7 goes in for the x there. Because it's the negative 1 power, we put it on the bottom of the fraction, make it positive. Now the domain of that function is all numbers except negative 3.5, because if I put negative 3.5 in here, I get a 0 in the denominator, and that's, you can't divide by 0. Okay, the other way, let's see, this one is g of f of x. So I'm plugging this equation into this equation. And 2 times 2 is 4, x to the negative 1. So the x goes in the denominator, becomes positive. And that would be all real numbers except 0, because you can't have 0 in the denominator. Okay, so they don't have that one, f of x there, so we'll skip that one for now. Okay, so that's a little coverage of section 6.3. We'll talk a little bit more about that in class tomorrow as well.